Hello, everyone. Welcome. Welcome. As you file in, don't hesitate to post in the chat. Tell us where you're coming from. We kind of have a global audience here at Encode Club, so it's always fun seeing what areas of the world. As I'm in kind of New York City in States time, we have people all over Europe, as well as South America, Africa, and even in Asia. So drop it in the chat, kind of get that chat going. But welcome. I'm Steve. I'm the program manager here at Encode Club, and this is going to be our next kind of workshop installment of the layer hack. This is going to be workshop number 5 with Boba. Very exciting stuff will happen today. Within this one, understanding kind of hybrid compute in more detail so you can build upon the challenge and really understand what's going on. It's also not too late to register. So if you're just seeing this for the first time, caught Boba at the right time and understanding hybrid compute, you can still register. So let me drop a couple links in the chat if you can still see it. That is kind of the updates from my side, as well as there will be a continuation of our last workshop later today in about an hour and a half. And then 2 weeks upcoming will be the submission. So things are going quickly. And you got about 2 weeks left. We're halfway through. So let me know if you have any individual questions or want to chat. But without further ado, we're all here for Boba and understanding hybrid compute. So I want to introduce our speaker for today, Kevin. He is a smart contract developer at Boba, and he will be taking on this workshop. And you can ask any questions you may have to him. Thanks for joining us, Kevin. I'll pass it over to you.
Yeah, thanks for having me. And yeah, looking forward to tell you the amazing stuff that we do at Boba. Just as a small heads up, if you have any questions, just drop them into the chat. I'm happy to answer them either during or after the workshop, depending on if it, disturbs the flow of my presentation. But in general, I prefer things having being like a little bit more interactive because that usually clears up more questions than creating more confusion throughout the presentation. Yeah, so welcome everyone. I'm Kevin, and as you already heard, I'm a smart contract developer at Boba. And in case you didn't know yet what Boba is an optimistic rollup on Ethereum, as many others, but in contrast, we modified layer 2 GEF and introduced some couple of new and amazing features. So one of the major features, and that's the one that we talk today about, is hybrid compute, or formerly known as Turing, which is basically just the same name for the same topic. And basically, the big USP here is hybrid compute enables you to do off-chain calculations or receiving off-chain data within one single atomic transaction. Like if you're a developer yourself, you know that with oracles like Chainlink, Yuma, and others, you usually need to wait some period of time before actually receiving the data, which is usually caused or based on the consensus model they have, right? To ensure that you actually get data that is, true or real. And at Boba, we basically introduced the model that you're actually able to do an off-chain call within one single transaction to improve the UX of your application, for example. We are right now entering a time in crypto where many, especially newer users, don't necessarily always care about maximum of trustless architecture and decentralization and so on, but rather actually want to have, for example, games, with a great UX. And that's basically what we are trying to do. Boba is a gaming chain or is focusing on gaming, and we want to enable games to create applications with amazing UX. Because right now, when we look at the space, we see that most of the games struggle with either attracting legitimate gamers that actually want to play for the sake of gaming instead of earning money, which is a big issue, and might be one of the reasons why many games long term beyond the hype fail, and also not have the best UX, right? Because in general, what all good games have in common is they have amazing UX, they are fun to play with, they don't make you wait. I think everyone has had some time when playing and you needed to wait, for example, with Skyrim back in the days, you needed to wait like a couple of minutes to get to the next scene or loading screen, basically the next opportunity to continue your gameplay. And that really, really removes a lot of fun from the game. So let's get a little bit more technical. We heard already that hybrid compute, formerly Turing, is some kind of pipe. That's actually the correct term for all that, but not an oracle that allows you to request off-chain data or do off-chain calculations in one transaction and get it back into your smart contract. So how is that done in general? Let me get the best slide for that. In general, the basic idea is that if you trigger that, let's say, API call from your smart contract, then you are estimating gas, like you're actually doing that estimation gas call on your front end, for example, which then triggers the actual API call, right, on layer 2 gas. And within a certain period of time, that result is cached. And when then actually calling that smart contract function, for example, your cached entry on layer 2 GAF is returned into the smart contract, which then enables you, as mentioned before, to actually get that result into your contract. And since that's not always suitable for, let's say, real-time data, because there might be some kind of delay, the biggest use case for that might be off-chain calculations, right? One interesting example that I like to bring is when you, for example, for whatever reason, want to calculate some complex mathematical formulas such as the special relativity theory of Einstein for whatever reason, as said, not having a special use case for that right now. But there are cases, if you're more experienced, where you need more complex mathematical structures, right? Is it a logarithm or things like that? And then you might encounter the issue at some point that you either need to implement some kind of estimation logic because Solidity doesn't have a efficient solution for that, or well, you might get into struggle with that, right? Especially on layer 1. But since that we are on layer 2 most of the time, we at least don't have a big issue with gas. Besides that, if it gets more expensive on layer 2 as well, then people, let's say, are not happy about that as well, even though if it's still way lower as on Ethereum, because the expectations are different. So to get back to the technical point, basically what you do is you basically do one smart contract call, but the actual API request is done a couple of seconds before when you estimate gas. So basically, when you do your actual smart contract call, layer 2 GAF basically intercepts the call, replaces the call data with the cached entry, and then puts both the original call data and the modified call data onto layer 1. So that's the basic idea of hybrid compute. And to give you some kind of overview of how that can look like, you basically have two major functions. Here's just one, two major functions. on one side, you can request a super strong pseudo-random number directly from layer 2 graph, which is, as we know, better than generating a weaker pseudo-random number on chain. But as mentioned before, in one single transaction, which is awesome. And on the other hand, we can actually request or trigger any API call to whatever REST API we want, right? So in general, the only thing that you need to do is having an API, or at least an intermediary API, if you, for example, want to request Twitter data, that returns the data in an ABI encoded format, right? But that's usually not the biggest challenge. For example, if you have an AWS Lambda function that actually triggers the API request to Twitter, for example, which doesn't implement that ABI functionality, but basically you on your own minimal backend trigger that API request or do your off-chain calculations, as mentioned before, some complex formula, and then you basically ABI encode that and return it back to the smart contract. So that's the general idea and the full magic beyond that. And the cool stuff actually is, when you think about it, it actually enables you to do new things, right? In general, you can do all things with oracles, or most of the things, in a quite somewhat trustless manner, right? Here, first time ever, you have the opportunity, the possibility to actually do that in one transaction. Right? If you use a regular oracle, users always have to wait, right? Or you rely on some previous state from previous transactions. So if another user is not triggering a new transaction, your actual result from Chainlink will never arrive. So in general, that enables you to do, for example, personalization stuff. For example, if just a super easy example in a data-driven world, you have your game, right? Usually a game, even if it's a Web3 game, might have, at least for caching purposes, some kind of backend, right? If it doesn't harm the ethics of the game itself. And what you could do then, for example, the user achieves some kind of quest. You did some amazing stuff in the game, and you now deserve that special achievement or skin, maybe a new jacket. And what you can do now is personalize that with data that you have about the user, right? And mint that directly to their wallet. So if you do that with oracles, you need to wait, right? And in the end, it's your endpoint anyway. So basically, you still always will have superior control over that. So for example, if I mint now that jacket and at the same time someone else also achieved that accomplishment, but since that they know I'm living in Austria or my favorite color is green or I don't know, the jacket will have some personalized nuances to it. Yeah, and that's nothing that you actually want to have on chain directly. But here you can bring these things in, right? That's just one of the many things that you could do from, let's say, a creativity standpoint, which will and is becoming much, much more important besides the better UX requirements that games and the apps are facing in general. So the cool thing is, yes, we now have the possibility to do off-chain calculations, to get off-chain data into our smart contracts and work with that, even complex types, by the way, if you want to return some kind of object or something like that. it's possible as well. What's super cool about the overall infrastructure of Boba itself is that Boba is the first ever, and when I say first ever, I really mean it, multi-chain for layer 2s, not layer 1s, but layer 2s, which means we have launched a layer 2 chain with that feature set on AVAX, on Phantom, on BSC, on Ethereum, and that enables you now to develop these kind of applications on different roll-ups for different layer 1 chains and even move assets between them. And that again gives you a new range of possibilities. So before talking about more stuff and possibly if you consider it like shilling our project, we'd love to hear a little bit about you. What are your needs, your problems, your things that your feedback, opinions on that, or questions, if you have any, because usually there are some, to maybe, yeah, discuss about all that in some kind of more interactive manner, right? Because it usually helps to drive the discussion to actually get some insights that I couldn't give you if I just continue talking all about myself. So in general, if there are no questions, please just drop them into the chat. I will just show you a couple of examples that we have built and use cases that one could do, which are way beyond gaming. Yeah. So I just wanted to give you a little bit of room to drop the questions, if there are some. In the meantime, I will just, let me check. Oh yeah, the screen sharing goes with me. Yeah, that's what I will do now. Anyway, showing some examples. Okay, well, I will start with an example that you don't like. We live or want to live in a quite decentralized and trustless ecosystem, right? That's the reason why blockchain exists. Unfortunately, when we think about it, or it also has its good sides, right? Regulation is coming in. We can't do nothing about it. And when we talk about regulation, one thing that happens or might happen is that governments require you to implement KYC. I hate it too. Nobody likes it. Everyone hates it. If we think about how it's done right now, for example, with the other side Mint, I think it was the private pre-sale, I'm not sure, but they had some kind of KYC mechanism. Basically, you had to KYC yourself somewhere to get onto their whitelist, which was then implemented with a Merkle proof, which is just some kind of CK mechanism, right? To verify that you have KYC'd yourself. So what one could do now is you could KYC yourself, and in contrast to actually saving it as a Merkle proof onto your smart contract, you could, for example, actually implement a super simple modifier that we have here, for example, already prepared, that does this API check for you. So example, let me check, where is it? Here we have a modifier, only KYC. So basically we can define functions in a very easy manner that only people that have KYC themselves against a trustworthy KYC provider, yeah, can actually call that function, right? We have here a require statement. And basically what's done here is from my essence, let's put it that way, we have our wallet address that we want to check if they are actually if that wallet is KYC, right? Thanks, Steve. And basically, we send that wallet to the backend by calling the so-called Turing helper contract. And how that works, I will explain that in a second. But basically, we call a smart contract, pass the API URL, and our API encoded request data, which in our case just contains the wallet address. And what we receive is a bytes value, and that bytes value can be decoded. In that case, I just decoded it as a numerical value, which, as we know, can then be distinguished as a Boolean, basically. So that basically, I will show you the exact use, for example, could be added here, but just adding only KYC to the smart contract function. And that would already restrict people calling it if they're not KYC'd. As before, I know we don't like it. We all want to be trustless. We all want to be censorship resistant. But that's unfortunately the world that we live in. And there need to be some kind of tools if you want to build something for the broad mass, which don't always need to have full decentralization. Need to be some kind of tools for them or for you as a developer to utilize. And that would be a super simple, but actually existing use case for that technology. Because checking if someone is KYC'd or not across different transactions, is a hassle, right? Can only be done actually with a Merkle proof. That could be another approach. It always depends on the use case, with what approach you want to go with. But in the end, it's the same, right? That's one thing that you could do. And before actually showing you how everything from a smart contract perspective works under the hood, I want to show you a use case where we queried just a random number so that you see that yourself. In this case, it was our NFT collection that we have launched on mainnet. And, oh, well, that was separation of concerns, I think, if I remember. Let me check. I think it was somewhere else. It was I think it was randomly assigned, right? Yeah. Well, basically the token ID is random for this NFT collection. So if you mint a new NFT, it's not incremented 0, 1, 2, 3, 4, but actually it's shuffled, right? You never know which token ID to actually receive when you mint a new one. So that can be done quite easily, again, in the same transaction, no callback as with Chainlink VRF, for example. But as mentioned before, different use case, right? Chainlink oracles are amazing. They have their use case. Hybrid compute is another one if your X is more important than decentralization, for example. So what you can do here, basically call again your so-called Turing helper, which means Turing, as said, old name for hybrid compute, so it's the same. Turing helper smart contract, and that function Turing random, which will then just return you a super strong pseudo-random number from layer 2 GAF. So, and we do some stuff with it. So basically, those are the two main ways to actually utilize hybrid compute, but there are different use cases for it, right? What we have done for our faucet, for example, we have authenticated faucet, and when you want to request your ETH, for example, or your Boba token, you need to treat a specific string, which is made up from your wallet address. on your Twitter account, and then you basically send the Twitter post ID to the smart contract and the wallet that you want to send the funds to. And then basically you do that off-chain call again, API URL with our parameters, which is in this case um, the, the, the to address, also the recipient and the Twitter post ID, I guess. Let me check where it is. Yeah, here, sorry, I'm so blind today. And when we get the data back, we basically decode it into 3 values that we need. So you basically could check if a user is actually a real one by forcing them to tweet on Twitter. You could, we have disabled that, but you could check for legitimacy. For example, does that account exist for more than 48 hours? Has it more than 20 followers? Has it tweeted three things in the last couple of years? You know, just to ensure it's a real person. If you want to do that, right? These are things that you could easily do with hybrid compute, but might be more challenging with an Oracle. I will show you one last use case that we already mentioned before I will explain you some more mechanics behind it. And that's an example that I've shown at ETH Bogota, I think 1 or 2 weeks ago. But basically calculating special relativity, maybe you need it for your game. You know, games get crazy sometimes. So why not? And basically that's for on-chain calculation, a quite complex formula, right? We have square root, we have power of 2, we have divisions 2 times. Yeah, it's doable on-chain, but not necessarily, yeah, you don't necessarily want to do that on-chain. So basically what you can do now, as you might guess already, that's the first time that we will see a full example. Oh yeah, let me check, local. What you can do, basically, you do that, also you pass the parameters that you need for the formula, in that case, a proper time and velocity to actually see how the time gets stretched when you move at a certain speed. And you basically encode those 2 parameters to get a bytes value, and then call the hybrid compute or Turing helper. As mentioned before, it's the same. With our Turing TX function, pass the API endpoint and the request data, and you get the result back. In our case, it's just a result of that mathematical formula. So we have talked about these 3 lines of code now a lot. So let's see how it works under the hood. In general, as you already see, we have some kind of mysterious smart contract here. What we need to do for sure is passing the address of that smart contract, have somewhere the endpoint that we want to call. And in that case, I just passed it with the constructor and save that with an interface into the smart contract itself. So that's the first thing. And based on the question, yes, when you do off-chain calculations, you don't have any gas costs for that. That's the reason why you actually outsource that calculation off-chain, to not pay all the gas that you would need if you do it in your smart contract. So the only thing that you need to pay to make that answer complete, just like with oracles, you need to pay 0.01 Boba per API call, and one Boba is around 20 cents right now. So you don't even need to pay, I think, 1/5 of 1 cent for one API request. So it should be quite affordable even for large scale projects. So basically that's all we need for our smart contract. No complicated callback that you need to track your request IDs and things like that. Really just doing a synchronous API request, get your data back, work with it. Awesome. So how does the backend actually look like? And what is now the mysterious Turing helper contract? Would be interesting to know, right? So the Turing helper contract is nothing that you would ever need to touch. It's a contract that you as a project founder needs to deploy for the simple reason that you can restrict other people from calling your smart contract, basically from calling your endpoint. You're basically restricting people so that you don't have to pay for other people's API request. Right? Would be if you don't want that to. Right? So basically, that contract helps you to whitelist smart contracts that are allowed to use your prepaid Boba balance, because as we know, you need to pay 0.01 Boba token per API call, which is a fraction of a cent. And basically, that smart contract basically just helps you to get better error messages, to track your prepaid balance, to restrict other people from calling it if you don't want it to, things like that. So as we can see, here is that famous Turing transaction function that you can use, and only whitelisted smart contracts are allowed to call it. But as said, you don't need to understand this smart contract. For sure, it wouldn't harm, but in general, just take it from an official source and you can deploy it, right? So basically, that's the magic. The same with Turing random here. And as you can see, this function basically calls itself basically from the outside to allow layer 2 GAF to intercept that call and replace the original call data with our modified call data that contains the previously cached API request. So that's basically the magic. And yeah, that's about the smart contract side. From the backend side, let me show that just to give you the full picture. I have here a Python file that you can upload, for example, on AWS Lambda functions, which then serves as a super minimalistic and very affordable backend. There's a lot of, it's not a lot of code. It's very manageable. But in general, all this code does is decoding the values that we passed with the Turing transaction call. We see that here. Like basically, we parse the values. We want to have our proper time and velocity parameter. And then we basically just do our mathematical calculation and encode it as ABI again to have our bytes value. And yeah, then we just pass it as within a JSON that the smart contract understands. And yeah, that's basically it. If you have a closer look at that, it's not that hard. It's very manageable. And as said before, it allows you to build, for especially games, where you're able to do things in a much more user-friendly fashion, which is, as mentioned before, gets more important every day, especially with the big Web2 companies coming in. And if you want to compete with that, you might need to do, unfortunately, some kind of trade-offs as well. So that's a magic behind that. I hope you got some kind of better understanding of how hybrid compute works, what it might enable you to do, why oracles are still awesome, and this is not a replacement for it, but yet it serves another use case and allows you to do things that you can't easily or can't do at all with oracles. And yeah, that since that Boba is a multi-chain layer 2, allows you to do even more amazing stuff. And because if you have some backend, you can also do some crazy stuff here, but be careful. So are there any questions? Would love to hear them. And yeah, if you want more examples, let me know, but it always looks the same. It's really just these 3 lines of codes, the same backend. If I create a new example, I always copy paste the original project and rename, refactor things, and replace the request parameters and so on. So it's super simple, really. And yeah, hopefully even simpler for your users. Okay.
Yeah. Any last questions for Kevin as we still got him on call for about 15 plus more minutes? Great resource. You can, like he said, he would love to hear kind of what you guys are thinking of building, how it kind of works out with hybrid compute, as they love the feedback. So please shoot away while we're on call here.
What we also have is, let me check if I remember the URL now. I think it was that one. For example, that's now for testnet. We also created a D app for that to actually make it even simpler. Basically, what you could do here, I'll just put the testnet link here. What you could do here, you could say, hey, I want to fund my application with 100 calls, which means 1 Boba, and that would cost me 20 cents around that with the current market prices. So you can see 0.01 Boba per call. So basically, the first one would just approving your Boba, as we all know it, your Boba tokens. Then what this does is you basically here are then okay, sorry. Haven't looked at that yet for a while. So basically what you pass here is, and I see that we should add that in the description because it doesn't say it right here. Here you can paste the smart contract that is allowed to call your endpoint, basically, which is then charged on your prepaid balance, right? So basically you can freely deploy your smart contract, and then you can paste the address here and click on that button, which will then deploy the Turing helper contract, deposit all Boba tokens for you, and whitelist your contract all out of the box. Nothing is needed here, anything else. And yeah. Okay, that's my own, let's say, that's my dark mode, I think. So basically what we have here is then just like the examples, step by step, again, explained how the backend can look like, but in the end, you just need to be able to decode the ABI encoded data and encode your result again. So that's the full magic behind everything. And yeah, I think my dark mode or my browser spoke because it looked better. Yeah, what we also provided, but that's the main specific now. We also have a SAM template for your AWS backend, where you actually can even upload your Python AWS Lambda with one single enter as well, which makes everything super easy again. But that's that DApp is completely optional and is actually just supposed to even make it more simpler for the developers to use hybrid compute. Yeah, but in general, if you look at any of the examples, it's really super simple. Everything is test-driven for us. We've written tests for everything, and it always happens the same, right? We deploy our own smart contract, we deploy the Turing helper, we send the Turing help, also the deployed Turing helper address and the API endpoint to that smart contract that we have implemented ourselves. Let's make it a little bit bigger, easier to read. And what we then need to do, as we know, we need to pay for the requests. Okay, that's specific to that smart contract now because it's a faucet. But in general, what we need to do is on one side whitelist our own smart contract, which is called Twitter in that case, on that Turing helper. And then we basically use, and that's what I didn't mention yet, we need to fund that Turing helper address basically with Boba tokens, so that this Turing helper is allowed to make X amount of calls. And basically we have deployed a smart contract ourselves. We usually call it Boba Turing credit, and there's just a function where you're able to add balance and say how many tokens do you want to deposit. Well, and that's my Turing helper. That one is allowed to use my balance. Yeah, and that's it, basically. Now you really have seen it all. And yeah, to also show you a call itself. Well, that's now, yeah, let's look at them. Well, the first thing, as we know, we need, so if we want to call our send funds meta function, it's just a name on our smart contract. We basically need to estimate gas before, because as you remember, the smart contract actually, or layer 2 gas actually does that API request here, like now, and caches the result. And when you then actually call your smart contract function, then this cached entry is used within a certain period of time. That's it. That's really everything, right? I know I've said a lot. I've talked an hour about it now, or not even an hour, let's say 30 minutes. But in the end, it's really on the smart contract side. It can even be one line of code, but usually I would recommend it's free because it's easier to read. And well, basically deploy your Turing helper, which is copy paste. Whitelist your own smart contract on the Turing helper and add funds to the Boba Turing credit contract by adding or submitting your Turing helper address. So that's really everything that you need to know. Your backend needs just to understand the ABI request, ABI encoded data, and needs to be able to return it. Okay, there's a question. I am thinking of making a MMO kind of game on Boba. What do you think? If doable, can you suggest some approaches? Well, since that we are currently onboarding a lot of even AAA games on Boba, but still are searching for a lot of new games, just reach out to our head of BD, which is James, or myself. We are actually actively supporting all or most of the game projects that are serious about building something. In general, I'm not a gamer, or not anymore a gamer myself, but from my understanding, MMO is that's text-based gaming. Is that true? like where you have your stories and you need to solve some kind of, let's say, clues or hints, and then you get to the next level or I don't know, next world. If that's true, yeah, sure, that's easily doable. We have, as mentioned before, we even have like shooter games that are actually building now, like not simple shooter games, but as mentioned, AAA games that are using hybrid compute for their uh, for themselves, because, as mentioned, it enables you to personalize things in your game on chain and just make it more user friendly. Massively multiplayer online game. Well, it's definitely easier with hybrid compute, but in general, everything that's multiplayer on chain is always challenging, right? Because transactions are not real time. Um, but yeah, definitely. Um, it makes things 100% easier and somewhat more trustless, or at least the feeling is more decentralized from the user perspective. So that's definitely something that you can do, but in general, the most challenging part might not be how to call um, API requests from a smart contract, but rather how you actually make that game on chain by itself, right? No matter the blockchain that you're on. That might be the bigger challenge here. Got some quality information on Boa. Would love to hear it. Maybe it's something that I don't even I know. But as said, Boba is a layer 2 multi-chain. So that's actually the next cool part. You can do things on different layer ones, actually, right? And even move assets between layer ones by using layer 2 chains. That's actually super powerful. And as mentioned before, if you have any, especially gaming projects that you want to build, reach out to us. Um, Actually, right now, it's our first priority to onboard as many quality projects as possible. And yeah,
Amazing. Thanks so much, everybody, for showing up to this Boba workshop.
thanks everyone.
Everything will be kind of posted here later on Medium as well as YouTube of a write-up of the event, as well as all of these resources that were posted by Kevin as well. So if you haven't seen our YouTube, please check it out here. And then we will be doing another event later today in continuation of this layer hack. So if you haven't seen that as well, building on ZK Sync 2.0, please check that out as well. But all this great information from Boba today, please check back on, as it's very key to building within this hackathon project. Would love to hear kind of what you're building on Boba, as well as kind of your pain points and issues. So I set up a time where you can actually book a call directly on my calendar if you would like to do that. So please let me know there. But other than that, thanks so much, Kevin, for joining us today. We really appreciate it. Sitting through, showing us some code, as well as answering our in-depth questions. Is there a good way to maybe reach you or follow you on Twitter or anything like that, to kind of hear what's next with Boba and announcements?
If
Great.
you want to reach out to me specifically, or if you want me to connect you with anyone of Boa, just hit me a message to do that as well. Okay, awesome. Thanks for having me as well. And if there's anything, just let me know.
Awesome. Thanks so much, Kevin. Thanks everyone for joining. See you all later. Have a great rest of your day. Bye-bye.